All right, let's talk about graphs of rational functions. In this first set of questions, we're matching graphs with rational equations in factored form. So let's start by looking at graph A. The things that we're looking for with a rational function are its roots, its asymptotes, whether or not it has tangency or togetherness, and then we want to consider the end behavior in the y-intercept. And we learned that in the form radii. So first of all, let's start with this graph on A, and let's notice the roots. This graph actually just has one root right here at -1. So my root is x equals -1. Now I know that the roots come from the numerator in my equation, and so in my numerator I'm going to have, since my root is at -1, I'm going to have the factor x plus 1. Let's move on to asymptotes. In this graph, we seem to have an asymptote right here at 2, and we also have another one at -2. So asymptotes at 2 and -2. The asymptotes, we find those in the denominator of our function. And so in my denominator, since I have an asymptote at 2, I would have the factor x minus 2. And since I have an asymptote at -2, I would have the factor x plus 2. Let's move on to the t. The t asks us to look for whether or not we have any turning points or tangency at the x-axis. And in this case we do. If you notice, right here at -1, the graph touches and then turns around. It doesn't cross the axis. We have tangency there. And so tangency is from the numerator. When we have factors squared in the numerator, it's happening at -1, which means my x plus 1 factor should be squared. Now togetherness, we're looking to see if our graph comes together around either of the asymptotes, and it does not. And let me erase this. Right here at our first asymptote, the graph is going up on this side and going down on this side. And then at the second asymptote, we're going down here and going up over here. So we don't have any tangency. So the only thing we have squared is that factor in the numerator. Now usually at this point, we should be pretty close to the equation, but we should always double check the e and the y to make sure that we're correct. My end behavior here, or my horizontal asymptote, is at, it's right here at y equals 1. And so since it's not at 0, that means that my exponents in my rational function should be the same. On the top here I have x squared, and on the bottom, if I multiply x times x, I would also get x squared. So my first terms would be x squared over x squared, which does give me a horizontal asymptote of y equals 1. And then finally, our y-intercept. It's right here on the y-axis, somewhere between 0 and 1. We can't tell exactly where it is, but it's a fraction, and it should be negative. And so let's check this out. If I were to multiply out my numerator, I'm sorry, let me back up. If I replace all of my x's with zeros, then y is equal to 0 plus 1 squared over 0 minus 2 times 0 plus 2. So on the top I get 1 squared, which is 1, and on the bottom I have -2 times +2, which is -4. So I have a y-intercept of -1/4, which certainly could be true about the y-intercept on the graph. So my equation is correct, and I'm going to erase everything. And that matches matches number 14. Number 14 should be answer A. Let's look at graph B. Again, we're going to start with the roots, which are at -1 and +1. And so -1 and 1, which means my equation In the numerator, because I have a root at -1, I would have x plus 1 in the numerator. Because I have a root at +1, I would have the factor x minus 1. All right, asymptotes for this graph happen at 2 and at -2. -2 and 2. Asymptotes come from factors in the denominator. If I have an asymptote at -2, I should have a factor of x plus 2. And if I have an asymptote at 2, I should have a factor of x minus 2. Tangency or togetherness. I look at my roots, and at both of those roots, the graph is crossing the axis. We're not turning around at either root, it's crossing. So I don't have any tangency, no turning points at my roots. Then if I check for togetherness, here at my first asymptote, the graph is going up on the left and down on the right. So no togetherness there. At the second one, we're going down on the left and up on the right, and so no togetherness there either. So we should have nothing squared in our equation. We can double check in behavior and the y-intercept. It looks like my horizontal asymptote is at 1, which means that my exponents should be the same in the numerator and the denominator, and they are in fact the same. And my y-intercept, it looks like it's a positive fraction. Let me mark that here, somewhere between 0 and 1. If I were to substitute 0 for all my x's, then I would get 1 times -1 over 2 times -2, which would be positive 1/4, which certainly could be true about that y-intercept. And so this is our equation for graph B, and that seems to match number 12. B for number 12. All right, let's move on to graph C. Actually, I'm just going to erase everything, and then I'll put back the B and the A. All right, let's look at C. Again, we're going to start with the roots. And it's kind of hard to tell on this one, but it looks like the roots are at -1 and 1 again. -1 and 1. And so for my equation, as we've seen previously, that means x plus 1, x minus 1 in the numerator. Asymptotes, again, at -2 and 2. And so we have seen before that that means my denominator would have the factors x plus 2 and x minus 2. Let's move on to tangency or togetherness. At my roots, the graph is crossing the axis at both of those roots. It's not turning around, and so we do not have any tangency. When I check for togetherness, here at my first asymptote, I'm going down on the left and I'm going down on the right around that asymptote. So I have togetherness right here at this asymptote. At the other one, I'm going down on the left and I'm going up on the right, so there's no togetherness at the other one. So I do have togetherness at x equals -2, and that's important because if it happens at -2, the factor that I get from x equals -2 is x plus 2, and so that's the one that should be squared. So if we move on to end behavior, this time it looks like my graph, the horizontal asymptote, is at 0. It's approaching 0, which means my exponent should be bigger on the bottom. And if you notice on the top, if I were to multiply this out, I would have x times x, or x squared. X squared on the top. But on the bottom, I have x squared times x, which would be x cubed. And so my exponents are bigger on the bottom, which means my horizontal asymptote is at 0. And my y-intercept, it looks like a tiny fraction, a positive number between 0 and 1. If I substitute zeros for my x's, I get 1 times -1 in the numerator, and in the denominator I get 2 squared times -2. So in the numerator I get -1, And in the denominator, I get 4 times negative 2, which is negative 8. And so that gives me positive 1/8, which does work for the y-intercept of this graph. And so this is our equation, and that matches answer number 13. Answer 13 goes with C. So now we have B, C, A. So obviously D goes with 15, but let's talk about it really quickly. Roots, again, at negative 1 and 1. Asymptotes are at negative 2 and 2. So again, I have x plus 1, x minus 1 in the numerator, x plus 2, x minus 2 in the denominator. Let's see what happens on our t's. I don't have any tangency or turning points at the roots. The graph crosses the axis at both of those roots, so nothing squared in the numerator. And for togetherness, my graph is going up to the left of this asymptote and down on the right of it. And then I'm going down on the right of this one and up on the left of this one. So I have no togetherness either. So I don't have anything squared. Next we should check our end behavior. Right, none here. End behavior. On this graph, it looks like our horizontal asymptote is up here at 2. And so that means that my exponents should be the same, which they are. In the numerator, I have x squared if I were to multiply x times x. And same in the denominator, x times x would be x squared. But in order to get 2, my coefficients should be 2 over 1. And so that is why this 2 has been added here in front. I'm going to put a 2 in front, which would make it 2x squared over x squared, which does give me that horizontal asymptote at 2. And so that's why this one is answer D. All right, let's move on to actually sketching graphs of rational functions. So you notice this is number 33 in your review. Let's start with this one. So R stands for roots, and roots come from setting our numerator equal to 0. And so in this case, the only factor in the numerator is x minus 2. And so x equal to 2 would be the value that would make that equal to 0. So x equals 2 is our root. And so I'm going to go ahead and start a graph over here. There's my root, x equals 2. Let's move on to A, which stands for asymptotes. Now asymptotes we get from setting our denominator equal to 0. Because remember, an asymptote is a place where the graph is undefined. And that happens whenever we divide by 0. So if I set my denominator equal to 0, if I look to see what makes the denominator 0, that would be at x equals negative 1 and at x equals positive 3. So I'm going to add my asymptotes over here on my graph. Here's negative 1 and 1, 2, 3, positive 3. There's my vertical asymptotes. Next up is the T, which stands for tangency or turning point if I have a squared in the numerator. And in this case I do. My factor in the numerator is squared. And so that means I'm going to have a turning point at x equals 2. Turning point at x equals 2. I don't have any squareds in my denominator, and so we will have no togetherness at the asymptotes. And that's important to remember, that there won't be togetherness, because that's going to help us sketch our graph later. We'll know that the graphs should go opposite directions around the asymptote. All right, for end behavior, we're looking for our horizontal asymptote, which means I need to figure out what's the degree in my numerator and what's the degree in the denominator. In the numerator, if I were to multiply that out, my first term would be x squared. And in the denominator, again, my first term would be x squared if I multiplied it out. First terms are all that matters for end behavior. My exponents are the same, and so I'm going to divide the coefficients to get that horizontal asymptote. In this case, my coefficients are both 1, and so my horizontal asymptote would be y equals 1. There we go, y equals 1. And finally, the y-intercept. To get the y-intercept, I want to replace all my x's with zeros. If I do that, in the numerator, I would have -2 squared. And in the denominator, if I replace the x's with zeros, I get 1 times -3. And so in the numerator, that equals 4. And in the denominator, I get -3. So -4/3 is my y-intercept. So I'm going to mark off, this is 1. -4/3 is bigger than 1, so I'm going to put it right here. Alright, so now we should be ready to sketch the graph. And the best place to start is with x-intercepts and y-intercepts. Here I have these 2 points. I'm going to use a different color for my graph. I know that these 2 points have to be connected. And if I look over here at my y-intercept, after that, my graph is going to go toward that asymptote. It's going to go down. Here at the x-intercept, this is where I need to remember that I do have a turning point at x equals 2. And so that means my graph is not going to cross the x-axis, but it's going to turn around and go back down toward this asymptote. So now I need 2 more pieces of the graph. Remember that we determined we have no togetherness. And so at this first asymptote, since the graph I've already drawn is going down, that means that my other piece needs to be going up so that I do not have togetherness. And the same is true at the other asymptote. The other piece needs to go up. And so that's our completed graph. Alright, let's move on to the next graph. Question number 34. We have this rational function. Now notice this time it's not in factored form for us, so we need to factor this before we get started on the radii. So x squared minus 1, that factors to be x plus 1, x minus 1. And then in the denominator, let's see, to get x squared, x and x, to get 4, 2 and 2, and they would both be positive. So that'll give me 4 as the last term, but it also gives me 4x in the middle. Now notice that there in the denominator, we have x plus 2 twice, and so we could write that as x plus 2 squared, which will be helpful when we get to the t part of radii. So let's go over to start with roots. Our roots are wherever the numerator is equal to 0. That's going to give us our zeros of the graph. And so my numerator is going to be 0 at -1 and at +1, because those are the numbers that make those two factors equal to 0. So I'm going to go ahead and start my graph over here. And I'm going to put a 0 here at +1 and a 0 at -1. Alright, next up is the asymptotes. Asymptotes come from the numbers that make the denominator 0. In this case, that's only -2. X equals -2 would be our only asymptote. So -2, mark it right here. And there's our asymptote. Alright, next up is t. If we have anything squared in the numerator, we would have a turning point, but there's nothing squared in the numerator, so no turning points, no tangency. If we have something squared in the denominator, then we have togetherness, and that is true for this equation. We're going to have togetherness at x equals -2. So we need to remember that when we're sketching our graph. E is the end behavior, so I'm looking at the exponents in my numerator and denominator. They are the same, exponents are the same, so we're going to divide coefficients, and they're both just 1. So my horizontal asymptote is y equals 1. And then for my y-intercept, if I change all the x's to 0, in the numerator I get 1 times -1, and in the denominator I have 2 squared. So in the numerator that gives me -1, and in the denominator 4. So my y-intercept is -1/4. So I'm going to say that's 1. We'll put -1/4 right there. All right, so now we're ready to sketch the graph. I like to start with the x-intercepts and the y-intercepts. These points have to be connected. So then we just have to figure out what happens on either side. Now remember, from our t, we have no turning points, which means my graph has to cross the x-axis at both of these x-intercepts. So over here at +1, the graph is going to cross, and it's going to go toward that asymptote and flatten out. At x equals -1, the graph is going to cross, and this time it's going to go up toward that vertical asymptote. We need one more piece over here on the left, and remember we determined that we do have togetherness at x equals 2, and so that means that if this part of the graph is going up right here, then my other piece must also go up so that they come together. And so that's our graph for question number 34.